All right, folks. So the lesson today is walking you through how we can calculate the thickness of a piece of metal foil like this one that is obviously way too thin for us to measure with our standard ruler that we have available to us. Since this only reads to the tenths, we can only estimate to the hundredths, and we're talking about thickness of this foil is in the thousandths. We can't measure it. We're going to have to use something called indirect measurement. So in science, there are often aspects of a sample that are either way too big or way too large for us to measure using the tools that we have available. One example is if we know that we have a mole of a substance, and we know that one mole has this many particles in it. That number is so big that we can't even imagine. It's basically 6 trillion trillions is what that is. That's massive, okay? This number is unimaginably large. So if you imagine a string, stringing one mole of paper clips together and wrapping around the earth, this would go around the world 400 trillion times. Just normal paper clips. That's a huge number. That would be a very, 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 very long string of paper clips. To determine very large or very small quantities, to deal with really, really big or really, really, really small things, we have to use a set of measurements or properties like density that are intensive properties to indirectly measure things. So we can use intensive properties that are independent of sample size. We can use intensive properties to indirectly measure quantities. In this lab, our normal tool, our ruler, is not sufficient to measure the thickness of our foil. So we need to calculate it. And we can take density and the volume formula, because really this sheet of foil is really a rectangular cube. We can easily see the length and the width. It's the height that's the unmeasurable piece. So if we think about volume as length times width times height, and we think about density as mass over volume, we can calculate or measure our mass. Since this is an elemental sample, we can know both mass and density, because we can look up the density of copper. You can just Google that. That'll let us find the volume. Once we calculate the volume on this side of our equation side, so we can find our volume. And once we find our volume, now we can plug that in over here. So find the volume, plug that in over here. Now we know volume. We can measure length. We can measure width. So the thickness or the height of the foil will be our unknown attribute. That's our immeasurable thing that we need to find through indirect measurement. So what we're going to have is a piece of foil. We got our ruler. We have our balance. And we are going to go through and take some measurements. So the first thing we're going to do is we're going to measure the width, the length, and the mass of our sample. And then we're going to calculate volume from density and mass. We're going to calculate volume from density and mass. and then apply that volume to our volume equation, the problem you're going to do on your own has a different volume equation because it's a volume of a cylinder. And that is going to be 2 pi r squared. We'll go into that when we get there in the activity. You'll see that equation is provided for you. But once we calculate the volume here, we can use it here. The length and the width, which we measure, are going to allow us to solve for height. And then we're going to compare that to the known height of the foil from the manufacturer. So that'll be provided for you. Okay? So on our little data sheet, and you're going to have something similar to this in the activity you're going to work on. If we take our mass, so we've already gone through and massed this out. And if I put my foil here, it's very important for me to write down my sample because there's about 25 different samples of this foil. So I'm going to take my width here, and I'm going to see if I line this up. I'm going to be very meticulous about lining everything up. And I'm going to have 8.4, let's say 8.42 is the width. And my length is right exactly on the 11.4. So I'm going to go 11.40. So now that I have my length, my width, and my mass, those are the only measurable things that I can use. I need to use the density of copper for this problem, because my sample is definitely copper and not aluminum. And I need to calculate the volume. Okay? So the way we're going to calculate volume, I'm going to go down below here. Okay? I know that density is equal to mass over volume. I know density and volume, so I need to find, I know density and mass. I need to find my volume. This is my unknown. We always want to get the unknown on top and by itself. So the first thing we want to do is we need to get this on top. So we're going to multiply both sides. We're going to multiply both sides by volume. If we multiply both sides by volume, my volume is going to cancel on the right, and I'm going to get a new equation. And that new equation shows me volume times density is equal to mass. So my volume, which I'm looking for V. My volume is now on top. So we have on top and by itself. We don't want V times D. We need V just by itself. So we're going to divide this side by D. Whatever we do to one side, we have to do to the other. We're going to see our density is going to cancel here. That gives us our final equation. And our final equation here is going to be the volume that we're looking for. This is our unknown, immeasurable piece right now. Volume is equal to mass over density. Now we can plug in our known values. We have 11.68 grams divided by your 8.96 grams per cubic centimeter. You're going to see the grams are going to cancel, and that's going to leave us with centimeters cubed, which is an appropriate unit for density. So 11.68 divided by 8.96 gives you 1.304. We'll just round it to there for right now. And that's going to be centimeters cubed. We don't have to do significant figures yet. We're only worried with significant figures at the very end of our problem. So volume, we do need to find volume. We're going to record that up here, but we're going to keep some extra numbers just until
we get the final answer. So the thickness of our calculated has to be in significant figures. Our final answer, we want to put in significant figures. So if we now think through the next equation is to find the thickness or the height. Okay? And that's going to be V equals length times width times height. Okay? The area would be the length times the width. So you can find the area and put that up there. We measured that already. So length times width would be 11.40 times 8.42. That's going to be 95.988. So area equals length times width. That's going to be 11.40 centimeters times 8.42 centimeters. And that's going to give you an area of 95.988 centimeters squared. And again, you don't have to worry about the significant figures yet, just in your final answer. So we can also look at volume is area times height. Okay, so we just found this 95.988. So we could say volume is equal to length times width times height, or our area times our height. We'd say volume or thickness can be found, the thickness is the height, and we can say volume is length times width times height, or we can say volume is area times height, or area times thickness. So if we do that, then to get the thickness by itself, we're going to have to divide both sides by area. So that's going to give me volume over area is equal to height, or the thickness. Okay. Now, if I plug these values in, I know my volume is 1.304 centimeters cubed. I know my area is 95.988 centimeters squared. So 1.304 divided by 95.988 gives me 0.0135585 centimeters. Okay, so that's my calculator answer. If you go back up and look at all your measurements from up top, all your measurements, 4 significant figures, 3 significant figures, 4, we have to go with 3 digits for our final answer. So our final answer, we're going to take this 1.013585, and we're going to round that to 0.0, doesn't count as significant, 136 centimeters. And that is going to be my thickness. The height and the thickness are the same thing. So 0.0136 centimeters is my thickness. So what we were able to do there was we were able to utilize density and mass that were known. We took mass and density and we found volume. After we found volume, we used the volume equation to find our thickness. If it's a cylinder, you're going to use it to find radius and then diameter. And the radius and diameter would be your thickness that you're looking for. And we used things that were measurable, mass, density, length, width, to find something that was immeasurable, which was the thickness. So the activity I'm going to ask you to look at now is an application of this, and you're going to use a different equation. So your equation is going to be for a cylinder, because you're going to analyze a wire sample. But in the meantime, if you need to think through the general process, which is take every measurable aspect you do know, mass, density, length, width, whatever you can measure, and solve for values that are going to get you closer to finding the known value, the unknown value that you can't measure. So in this one, we couldn't measure the thickness, so we had to find the volume from density and mass. So you always are going to find the volume from density and mass, and then use the volume equation to solve for that immeasurable aspect. So the activity attached to this video is what I'd like you to work on. See how far you can get today. We'll have some more time to work on this on Monday as well. And we'll also have some Q&A time at the beginning of Monday to kind of go through any of the problem solving that areas where we get jammed up today. So try to get as much of this done. I'm not going to walk you through the entire calculation for this until after it's due for the assignment. But think about the process we did here. We used mass and density, which were known, to find something unknown. Because the volume that you calculate from density is going to be the volume you're going to use with your geometric equation. In the activity, it's going to be for a cylinder.